In this video, I want to explain the findings of one of our recent research studies that explored how long-term soil management influences the soil's ability to store and supply water to plants. Soil water availability is not determined only by rainfall or irrigation. It is strongly shaped by soil structure, pore distribution, and the way land has been managed over many years. Understanding this relationship is essential for improving crop productivity and resilience, especially under increasing climate variability and weather uncertainty. The focus of this study was plant available water capacity, which represents the amount of water that soil can actually deliver to plant roots. This is a key indicator of soil physical quality because it directly affects plant growth, drought tolerance, and overall system sustainability. We examined a long-term no-till system that has been maintained for nearly 3 decades and compared different management approaches, including a fallow treatment with no inputs, a cover crop system, and soils receiving regular applications of compost or manure. By evaluating these systems side by side, we wanted to understand how different organic inputs influence soil water behavior over time. Our results showed that long-term organic amendments significantly changed how soils retained and released water. Soils receiving manure consistently demonstrated greater plant available water in the surface layer, meaning they were better able to store water and gradually supply it to plants when needed. Compost increased total porosity and water retention as well, but much of that water was held in very small pores, making it less accessible to plant roots. Cover crops provided moderate benefits by improving soil function and pore activity, although their effect was smaller compared to direct organic amendments. In contrast, soils left in fallow conditions sometimes stored water deeper in the profile, but much of this water was held too tightly to be effectively used by plants. The key reason behind these differences was not simply the addition of organic matter, but the way long-term inputs reshaped the soil's pore structure. Organic amendments improved aggregation and increased the proportion of mesopores, which are the pore sizes most responsible for holding water that plants can actually access. This structural improvement enhanced the soil's hydraulic function, allowing water to be retained without becoming unavailable. We also observed that bulk density played an important role, as denser soils restricted water availability, highlighting the importance of maintaining good soil structure alongside organic inputs. Overall, this study demonstrates that soil management creates lasting legacy effects on hydrologic behavior. Sustainable practices such as long-term organic amendments can transform the physical architecture of soil, improving its ability to capture, store, and deliver water over time. These changes are especially important for building climate-resilient agricultural systems that can better withstand periods of drought or irregular rainfall. In summary, improving soil water availability is not only about increasing moisture content, but about creating a functional pore system that balances storage and accessibility. Long-term soil stewardship, particularly through organic inputs and conservation management, plays a critical role in enhancing soil quality, supporting plant growth, and ensuring sustainable productivity for the future.